Bright Tuty. Every student matters.
So observe the multiplication fact illustrated by the following diagram. Now you have to observe this. Now count the number of dots in figure 2.1a, okay, and figure 2.1b. So you have to count the number of dots in 1a and 1b, and then you have to answer what you get. The number of dots is the same. So let's count the number of dots. So we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 and 24. Okay. So there are 24 dots in 2.1a, and let's call out the number of dots in 2.1b. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 and 24. So we have got 24 dots in 2.1b as well. So in figure 2.1a we have 2 into 3 dots in each box. So the total number of dots is 2 into 3 then into 4, because we have got 4 such boxes which has got 2 into 3 dots. Now in figure 2.1b each box has 3 into 4 dots, right? And overall we have got 2 such boxes. So number of dots is 2 into under brackets 3 into 4, that is 24 dots again. So 2 into 3 under brackets into 4 is equals to 2 into under brackets 3 into 4. Similarly, you can see that 3 into 5 under brackets into 4 is equals to 3 outside of bracket into 5 into 4. Now, same thing you can try out for any number of multiplication. So, let's try this out. 5 into 6 inside the bracket into 2. So, let's just calculate this. You know that 5 into 6 is 30 and 30 into 2 is equals to 60. Okay. Now, let's count this. Now, this is 5 into under bracket 6 into 2. Okay. Now, 6 into 2 is how much? 12. So, 5 into 12 is again 60. So, we have got 60 is equals to 60. So, both the values are same, right? Similarly, we have got 3 into 6 inside bracket into 4, and this is equals to 3 into inside bracket 6 into 4. So, we have got now 3 into 6 is 18 and 18 into 4. How much is 18 into 4? It is 72. Similarly, we have got this 6 into 4 is 24. So, 3 into 24 is again 72. So, both the values are same. Thus, what we find over here is associativity property for multiplication of whole numbers. So, this property means associativity property for multiplication of whole numbers. So, A into B into C, if this is equals to A into B into C, this means this is associativity property for multiplication of whole numbers. Okay. Now, let's see this. Now, think, discuss and write. Now, think on and find which is easier and why. So, we have to find out which one is easier and why. So, let's see. 6 into 5 into 3. Okay. So, let's just or 6 into 5 into 3 inside of bracket. So, let's see this one first. Now, 6 into 5 is how much? 30, and 30 into 3 is 90. Now, over here 5 into 3 is 15 and 6 into 15 is again 90. Okay, so which one is easier? I feel this one is easier, because if here we got 30 into 3, now we can directly multiply this as 3 into 3 into 10, that is 9 into 10, that is 90. So, comparatively, this one is easier. Okay, I think this one is easier. Now, let's see this. 9 into 4, okay, we have got 9 into 4 inside of bracket into 25, or 9 into inside of bracket 4 into 25. Okay. Now, 9 into 4 is 36 and 36 into 25. Now, this is a little difficult to calculate. Now, let's calculate this one. Now, this we have 9 into inside of bracket we have got 4 into 25. Now, 25 into 4 is actually 100. So, this is much easier to calculate. We got this as 900. If we are going to calculate this, so this is 2-digit number multiplication with another 2-digit number. So, this is a longer calculation. If we do it, 36 into 25, let's calculate this. 5 into 6 is 30, so 0, carry over 3. 5 into 3 is 15 and 15 plus 3 is 18. Now, 2 into 6 is 12, so 2, carry over 1 and 2 into 3 is 6, okay, and 6 plus 1 is 7, right? So, we have 0, 8 plus 2 is 10, so 0, carry over 1. We have 7 plus 1 is 8 plus 1 is 9, so we have got 900. So, we have got 900 is equals to 900, that is 9 into 4 into 25 is equals to 9 into 4 into 25, and the result that we got is 900. So, this calculation is easier, okay. This calculation is easier, okay. So, if we have got associativity, if we can apply associativity for multiplication of whole numbers, then we can even find out, or we can easily calculate the same three set of numbers, okay. So, we have different ways to calculate it. So, we can multiply, the order of multiplication of whole number is not at all important. So, we can easily calculate the value, okay. Now, let's see an example. Find 14 plus 17 plus 6 in two ways, okay. So, let's see this. Okay, so we can write this as 14 plus 17 inside of bracket plus 6, and 14 plus 17 if you add, let's add this. We have got 7 plus 4, that is 11, so 1 carry over 1, and we have got 1 plus 1 is 2 plus 1 is 3, so we have got 31, and then we have got 31 plus 6, so that is 37. Now another way is, okay, so here we have got 14 plus 17 plus 6, okay. And if we add it like this, we add 14 plus 6 first. So, this gives me 20 and 20 plus 17 is 37. So, this is easier. So, you have used a combination of associativity and commutative properties for addition. So, this is associativity as well as commutative property for addition. Do you think using the commutative and the associative property has made the calculation easier? So, yes, definitely yes. Now, associativity means the order is not important at all, okay. So, we have got 14 plus 6, we have put it inside bracket and then added 17 to this, okay. So, this is associativity, right. Now, the associative property of multiplication is very useful in following types of sums, okay. Now, let's see this. We have got to find 12 into 35. Now, let's find this out. How will you find this? Now, 12 into 35, we can break this as over here, okay. So, this is 6 into 2, that is 12, and this into 35. Now, 6 into 2 into, we can also change the order over here. So, we have got 6 into 2 into 35, okay. Now, 2 into 35 is 70 and 6 into 70 is 420. So, in the above example, we have used associativity to get the advantage of multiplying the smallest even number by a multiple of 5, okay. So, associativity means we can break this, okay, very easily. Now, find 8 into 1769 into 125. Now, the way I see this is, see, we have got to calculate 8 into 1769 into 125, okay. So, if we do it like this, 8 into 125 and then multiply this with 1769, okay. So, if we do this, so we have got 125 into 8. Now, let's calculate this. 8 into 5 is 40, so 0 carry over 4. 8 into 2 is 16 and 16 plus 4 is 20, so 0 carry over 2. And 8 into 1 is 8 plus 2 is 10. So, we have got 1000. So, we simply have 1000 into 1769. Okay. So, this means 1769 and then 3 zeros. So, this is what the answer is, and we got this answer quite easily. Okay. So, the different properties for addition and multiplication, the different properties that can be applied over the addition and multiplication of whole numbers makes our calculation quite easy. So, if we know those properties quite well, then that is going to make our calculation very easy. Now, let's move ahead. So, we have to find out 7 plus 18 plus 13. Okay. So, let's try to find this out. So, we can break this as 13 plus 7, okay, and then 18. Now, 13 plus 7 is 20 and 20 plus 18 is very easily we can write this as 38, okay. Now, another is 16 plus 12 plus 4, okay. So, we have got 16 plus 4, this is 20 and then plus 12. So we have got 20 plus 12. So this is equals to 32. Okay. Now let's find this over here. We have got 25 into 8358 into 4. Now applying the properties. We have got 25 into 4 if we put it like this into 8358. Now we know that 25 into 4 is 100. So 100 into 8358. So then what answer we will get? So 8358 and then 0, 0. Okay. Now next is 625 into 3759 into 8. So let's calculate this. Okay. So if we multiply it like this, so if we multiply it like 625 into 8 first and then into 3759. Okay. So 625 into 8 if we do it like this, so we have got 8 into 5 is 40, so 0 carry over 4. 8 into 2 is 16 and 16 plus 4 is 20, so 0 carry over 2. 8 into 6 is how much? 48 and 48 plus 2 is 50, so we have got 5000. So we directly have to multiply 3759 into 5000 or 3759 into 5 into 1000, right? So we can easily calculate 3759 into 5, right? So we have 5 into 9 into 5 is 45, so 5 carry over 4. 5 into 5 is 25, 25 plus 4 is 29, so 9 carry over 2. 5 into 7 is 35 and 35 plus 2 is 37, so 7 carry over 3. 5 into 3 is 15 and 15 plus 3 is 18. So what do we get? We get 18795, that is 18,795 into 1000. So what do we get? We get 18795 and then 000. So this is the answer that we get. Okay. So we get 1,87,95,000. So this answer we have got. Okay. Right. So is 16 divided by 4 divided by 2 equals to 16 divided by 4 divided by 2 in brackets? So let's try and find this out. Okay. So 16 divided by 4 divided by 2. So you know that whenever any operation is present inside the bracket, right? So that operation we perform first, right? So 16 divided by 4. So you know 16 divided by 4 is actually 4. So we get 4 divided by 2, right? So the answer is 2. Now if we do it like 16 divided by 4 divided by 2. Okay. Now again we will perform the operation inside the bracket first. So this will give me 16 divided by, now 4 divided by 2 is 2. So this will give me 2. So 16 divided by 2. So this is going to give me 8. Okay. So the answer is different. So what do we get over here? We get that 16 divided by 4 divided by 2 is not equal to 16 divided by 4 divided by 2. So is there an associative property for division? So no, there is no associative property for division. Now discuss with your friends. Okay. So what are we going to write? We'll write that no, there is no associative property for division of whole numbers. Okay. Right. Now you have to think and write this. Okay. So discuss with your friends. Now think of 28 divided by 4 divided by 2. Okay. So let's try this out. We have got 28 divided by, 14, right, and divided by 2, and next we have 28 divided by 14 divided by 2. Okay, right. Now if we do the calculation, now 28 divided by 14, so 28 by 14, this is actually equals to 2, so we have got 2 divided by 2 and this is equals to 1. And then we have 28 divided by 14 divided by 2. Now 14 divided by 2 is, 14 by 2 is actually 7. So we have got 28 divided by 7 and this is 4. So this means here we got the answer as 1 and here we are getting the answer as 4. So this means that 28 divided by 14 inside bracket divided by 2 is not equals to 28 divided by inside bracket 14 divided by 2. Okay. Right. Now moving forward, now we have to do this. we have to see about distributivity of multiplication over addition. Okay. Now take a graph of size 6 centimeter by 8 centimeter. So we have taken a graph of size 6 centimeter by 8 centimeter. Okay. We have got 6 centimeter in the width. So we have got, you see that this, the edge of each box denotes 1 centimeter. So we have 1, 2, 3, 4, 5 and 6 centimeter in width. And we have got 1, 2, 3, 4, 5, 6, 7 and 8 centimeter in length. Okay. So we have got 6 centimeter by 8 centimeter having square of size 1 centimeter into 1 centimeter. Now how many squares do you have in all? So let's, if we are going to calculate the squares, it is going to be very lengthy. So we have got 6 squares in each column. Okay. And we have got 8 squares in each row. So we have got 8 into 6 or 6 into 8, that is equals to 48 squares. So we have got how many squares? 48 squares. Now cut the sheet into 2 pieces of 6 centimeter by 5 centimeter and 6 centimeter by 3 centimeter. Okay. So this is 6 centimeter by 5 centimeter. Okay. So this is 1, 2, 3, 4 and 5 squares, and this is 1, 2, 3, 4, 5 and 6. This is 6 centimeter and this is 5 centimeter and this is 1, 2, 3, 4, 5 and 6. This is again 6 centimeter and this is 3 centimeter in width. Okay. Now number of squares, it is 6 into 5. Now this square is 6 into 5. This is equals to 30. Number of square over here is 6 into 3. This is equals to 80. In all, how many squares are there in both the pieces? So we have to find the number of squares in both the pieces. It is 6 into 5 plus 6 into 3. Right? It is 6 into 5 over here and 6 into 3 over here. So does it mean that we have got 6 into 8 is equals to 6 into 5 plus 6 into 3? Right? Because the number of squares in total is also same, because 30 plus 18 is again 48, which was actually equal to the original number of squares. So what we can do is we can say that 6 into 5 plus 3 inside bracket is equals to 6 into 5 inside bracket plus 6 into 3 inside bracket. Similarly, you will find that 2 into 3 plus 5 is equals to 2 into 3 plus 2 into 5. So this is known as distributivity of multiplication over addition. Now find using distributivity. Now we have to find the value of these. Okay, so let's try it out. So we have to find the value of these using distributivity of multiplication over addition. So we have got 4 into 5 plus 8. Okay, so this gives me 4 into 5 plus 4 into 8. Okay, so this is 4 into 5 is 20 and 8 into 4 or 4 into 8 is 32. So this is 52. Okay, then we have 6 into 7 plus 9. Now what can we write this as? This is 6 into 7 plus 6 into 9. Okay. 6 into 7 is 42 plus 6 into 9 is 54. So we are going to add 54 plus 42. Let's add this. We have got 4 plus 2 is 6 and 5 plus 4 is 9. So the answer is 96. Okay. Now next is 7 into 11 plus 9. Okay, so we have got 7 into 11 plus 7 into 9, right? Now 7 into 11 is 77 plus 7 into 9 is 63. So let's add this. So we have got 77 plus 63. So we have got 7 plus 3 is 10, so 0 carry over 1, and 7 plus 6 is 13, 13 plus 1 is 14. So the answer is 140. So applying the property of distributivity of multiplication over addition, we have calculated the following. Let's move forward. Okay. Nothing, discuss and write. Okay. So observe the following multiplication and discuss whether we use here the idea of distributivity of multiplication over addition. So over here, are we using the idea of distributivity of multiplication over addition? Let's see that. We have to multiply 425 with 136. Okay. Right. So we'll start with multiplying the first digit. Okay. With all the digits. Right. So we have got 6 into 5 is 30. So 0 carry over 3. 6 into 2 is 12. 12 plus 3 is 15. So we have got 5 carry over 1. then 6 into 4 is 24, 24 plus 1 is 25, okay. So this is 425 into 6, then we are going to multiply with 30, we are going to multiply 425 with 30, so the answer that we get is this, that is 12,750, and then we are going to multiply 425 with 100, so the answer that we got is 42,500, and then we are going to add them all. So the answer that we got is 57,800, okay. The answer that we got over here is 57,800. So this means that what have we actually done, right? What have we actually done over here? We have multiplied 425 into 136 or 425 into, this is 136, I will write this again. This is 425 into 136, okay. So this is actually 425 into 100 plus 30 plus 6. This is what we have done. So we have actually applied distributivity of, so this is actually, we have applied distributivity of multiplication over addition. So we have actually applied this, okay. Now let's move forward to see the next example. Now the school canteen charges rupees 20 for lunch and rupees 4 for milk each day, okay. So how much is the school canteen charging? Rupees 20 for lunch and rupees 4 for milk, okay. So how much money do you spend in 5 days on these things? Okay, so how can we find this? Now find the amount for lunch for 5 days and find the amount for milk for 5 days and then add it. So cost of lunch for 5 days is 5 into 20, that is 100 rupees, and cost of milk for 5 days is 5 into 4, that is 20 rupees. So total cost is 100 plus 20, that is 120. Okay. Now find the total amount for 1 day. So how can we find the total amount for 1 day? So in that case, another method is that we find the total amount for 1 day and then we multiply it by 5. Okay. So cost of lunch plus cost of milk for 1 day is 20 plus 4, that is 24. And then cost for 5 days is 5 into 20 plus 4, that is 5 into 24. So 120 rupees. Okay. So this means this example shows that 5 into 20 plus 4 is equals to 5 into 20 plus 5 into 4. So this is the principle of distributivity of multiplication over addition. Okay, let's see another example. We have to find 12 into 35 using distributivity. So how can we write this? We can write this as 12 into 30 plus 5, right? So we can do it as 12 into 30, okay, plus 12 into 5. Now 12 into 30 is 360 and 12 into 5 is 60. So we have got 360 plus 60, that is 420. Another number is we have to simplify 126 into 155 plus 126 into 45. Okay, so how can we simplify this? Right, so this is actually distributivity of multiplication over addition. So we can simplify this as, see, 126 into, this is 126 into 55 plus 126 into 45. So how can we do this? We can do this actually as 126 into 55 plus 45. Now if I am going to add 55 plus 45, how much do I get? 5 plus 5 is 10, so 0 carry over 1. 5 plus 1 is 6 plus 4 is 10. So we have got 100. So we have got 126 into 100, that is 12,600. Okay. Now let's try this out. Okay, so let's try this out now. We have to find 15 into 68. Okay, so let's try to find 15 into 68. We will use distributivity of multiplication over addition. So distributivity of multiplication over addition. Okay, so how can we write this? We can write this as 10 plus 5 into 68. We can write this, right? Okay, so we have got 68 into 10 plus 68 into 5, right? So we have got 680 plus, we can easily calculate 68 into 5. Let's do that. So 5 into 8 is 40, so 0 carry over 4. Now 5 into 6 is 30 and 30 plus 4 is 34. So we add 340 to this. Now if we are going to add these two, 680 plus 340, what do we get? 0 plus 0 is 0, 8 plus 4 is 12, so 2 carry over 1. 6 plus 3 is 9 and 9 plus 1 is 10. So this is 1020. Okay. Okay, so next question that we have is, we have to calculate 17 into 23. Okay, so what do we have to calculate? We have to calculate 17 into 23. So how can we do that? So we can do this as 17, we can write it as 10 plus 7 into 23. So this actually becomes 23 into 10 plus 23 into 7 plus 23 into 7. 23 into 10 is 230 and 23 into 7, let me calculate it in rough over here. So 7 into 3 is 21, so 1 carry over 2 and 7 into 2 is 14 and 14 plus 2 is 16. So I've got 161. So the answer is 230 plus 161. Okay, so 0 plus 1 is 1, 3 plus 6 is 9 and 2 plus 1 is 3. So the answer is 391. Okay. Now let's get back. Now we have to calculate 69 into 78 plus 22 into 69. We have got 69 into 78 plus 22 into 69. Okay, 22 into 69. Okay. So what can we do over here? So this is actually, if we are, so this actually means if we take 69 common over here, so this actually means 69 into 78 plus 22. Now you know that 78 plus 22 is how much? 100. 8 plus 2 is 10, so 0 carry over 1. 7 plus 2 is 9 and plus 1 is 10. So we have got 69 into 100. So this gives me 6900. Okay, so this is my answer. The answer is 6900. Okay, using distributivity property. So moving forward, students, we have another topic in whole numbers, that is identity for addition and multiplication. Okay. So let's talk about identity for addition and multiplication. So how is the collection of whole numbers different from the collection of natural numbers? So how is it different? You know that in case of whole numbers, it includes 0 plus the complete set of natural numbers. So it is just the presence of 0 in the collection of whole numbers. Now this number 0 has a special role in addition. Okay. The following table will help you guess the role. When you add 0 to any whole number, what is the result? So if you are going to add 0 to any whole number, the result is the number itself. Like 5 plus 0, you are getting the number itself. 0 plus 15, you are getting the number itself. 0 plus 26, you are getting the number itself, and so on. Okay. So it is the same whole number again. So 0 is called an identity for addition of whole numbers or additive identity for whole numbers. So what is 0? 0 is an identity for addition of whole numbers. Now 0 has a special role in multiplication too. Any number when multiplied by 0 becomes 0. So for example, if you observe this pattern, 5 into 6 is 30, 5 into 5 is 25, 5 into 4 is 20, 5 into 3 is 15, 5 into 2 is, what do we get? 5 into 2 is 10, and 5 into 1 is 5, and 5 into 0 is 0. Okay. So observe how the products decrease. So you see that the product is decreasing by 5, right? Each time it is decreasing by 5. So in this pattern, is this pattern true for other whole numbers also? Okay. So same pattern is true for other whole numbers. So you come across an additive identity for whole numbers. A number remains unchanged when added to 0, right? So this is the additive identity for whole numbers. Similar is the case for a multiplicative identity for whole numbers. Okay. So we have the similar case for multiplicative identity. So you can observe this table. 7 into 1 is 7. 5 into 1 is 5. 1 into 12 is 12. 1 into 100 is 100, and so on. So 1 is the identity for multiplication of whole numbers or multiplicative identity for whole numbers. Okay.